since spiral CT has come up, so there are more than one slice CT nowadays. Usually we call it multi-slice because the CTs are available from right from dual 2 slice to almost 384 slice nowadays, and around 700 something is under research. Though Siemens has put one CT, I'm not sure, I think coaching, which is of 784 or 83 slice for some research purpose. So what happens in multi-slice? We are acquiring more data. So as we acquire more data, the image quality improves. So it's like, see, if it is a table, and see, like if it is a tube, so it rotates like this. So in multi-slice, for one, say like for this much, we rotate it twice or thrice. So we are acquiring more data. So more the data is acquired, better the image quality. And better the image quality, so we call it everything is better in this multi-slice. See the resolution, this is the image resolution for a quad. Quad means you can say it's more than 4 slices, so the image quality becomes 4 times or 8 times better. Whereas the speed, volume and power data is the same. So we are using the same tube, same detector, but better image quality. So what does the CT show? In engineering language, so this is CT numbers. You can see over here in the image. See, is this visible? So this is the house field number, or we can say HN number for different anatomies. Like for this is for bone, this is for spongy bone, or you can say cartilage. See, the CT numbers is measured in HN. CT numbers of water and air is 0 and 1000. So all the images are in range between 0 to -1000. But where the medical scanner works between -1024 to +3071 HN. See, from here you will have a better perspective. This is the distance between 2 collimeters. Assume this is a source. This is the distance between 2 collimeters. We keep on increasing our distance. See what's happening. Now, we all know, to penetrate a bone, we require more power. Whereas for fat or for a softer tissue, we require less power. So this is the density graph. This is for bone and respectively. You can see this is -1000 and this is +1000. Now that was something bookish kind of thing. Now let's move to what's happening in the industry at present. So present days CT X-ray tubes are very different from the conventional one. Nowadays single tube is used to penetrate on the same patient. Like how I'm not able to run that video. Whether you have a C-stop video. Check. I don't know why I'm not able to run, because that video was tubes are having a graphite coating behind. It's a new technology what we are using in our present CTs. So like you can see in this tube, the two rays are coming out from the same source. So it's like you are bombarding 2 different sources. It's like 2 tubes working for you on one patient simultaneously. So you are actually taking out you can say like 2 doses or say like 2 number of rays for one patient. So, okay, a very practical question. What is the expectation of from an engineer, I mean, when we talk about any medical technology, first of all, technology, that is like medical advancement in which your inventions or your development helps in clinical perspective, the efficiency of your discovery or invention or your work, and for the patient, like how caring you are for the patient. As I gave you the example of a pacemaker, so it's quite similar like this. And last is cost. Because if you just invent something which is crazy expensive, no one is going to buy it. So this is what patient care is. You can see he is an obese patient. So nowadays a CT is present with a white board. Earlier it used to be in a shallow board, like the whole side was less. And nowadays we got a wider board, so even an obese patient can go inside without feeling claustrophobic. So this is a new advancement in the field of CT. Plus dose reduction. Dose is a very, very important thing when we talk about Europe or developed nations like US, Europe and other countries. There this dose plays a huge role. So our companies runs or shuts down because of this dose things. So see, as we had covered in the previous slides, this is a gantry. The X-ray source is moving like this, and the detector as well. So see the anatomy. Like for example, if you see a patient to penetrate a chest, okay. So if a source is from this side, the detector is on your behind. So the depth is less. So you require a lesser dose. But whereas when the source, the X-ray tubes come on this side and the detector is on this side, the width is more. So you have more dose. So nowadays technology has come up which keeps on changing as per your anatomy. In earlier days, the dose, say like X dose was there for this depth, for every area. But nowadays there is specific so that you are exposing less to the patient. And this is a very vital, I mean in present industry, this is a very vital thing. Now this is faster scanning speed. As in my first slide, I guess I had shown you a CT scanner whose acquisition time was almost 7 minutes. And see, less than 1 second nowadays. So this is adaptive in mostly in cardiac. Now again, this is a new application which has come up. What is automatic topograph? So now the machine itself determines what is the amount of dosage to be given to the patient. See, like if you're seeing this yellow box, it is covering the spinal cord. So in a spine, so since it being a bony structure, you require more dosage. So in this orange thing, you are seeing the whole body, right? In the purple, it's mostly lungs or the cardiac region, so you require less dosage. So the machine calculates accordingly and exposes you accordingly. Now, this is the latest advancement, what is dual source CT. Presently this technology is only with Siemens, then it's not being, Netra, correct me if I'm wrong. This technology is only, since he's been from Germany, I mean from last month he was there, so he's been knowing this. So dual source CT. In this, in earlier days it was very hard to manage one X-ray source and one detector in one gantry. But nowadays, there is two sources. This is source number 1, this is source number 2. That means 2 X-ray tubes in one gantry plus 2 detectors. See, these are 2 rows of detectors which is perpendicular to each other. So now both rotates simultaneously. So this is mostly used in cardiac. I think we had installed a couple of these. So mostly the cardiac hospitals are using it because the scanning time is very fast. See the difference between a single source CT and a dual source CT. There is just one source and one rows of detector, whereas here you got 2 X-rays and 2 rows of detectors. the example of a cardiac scan using a dual source. So this is a single source in which the red thing is overlapping of the images. Like you are exposing a patient twice for one anatomy, whereas in this you are not exposing the patient twice. These are a few of the clinical images. Anything familiar? I mean, does anyone have any doubt about these images? Want to know anything about this image? What will be this one? This one? Sorry? Yeah, exactly. Yeah. So these images, if we talk about these softwares, there are huge advancements in CT software. We in our professional we call it applications. So these all are like 3D images which have been reconstructed using the data acquired by the gantry or the CT scan. So it has been reconstructed, or you can say post processed in a 3D form. Okay, this is I mean, you don't know this, and this is neuroperfusion. Alright, thank you so much. Any questions? The statistic is very high.
Okay, the speed is very
Statistic is very high. The whole scan takes in around 0.3 seconds. So basically, it's used in cardiac. Most of it is finding application in cardiac mostly. Because cardiac is heart is a moving organ. So if you need, in earlier days we used to give a beta blocker. So by giving a beta blocker, we used to reduce the heart rate to capture the image. But in dual source, you don't require to slow down the heart rate.
I think whether can you able to get a soft tissue information also?
Yeah, of course. Yes.
Because it's a dual source CT. Yeah. I think for subtracting the bone component, with the difference in attenuation, dual source CT.
No, you're talking about dual energy. Dual energy is a different, like you said, like for example, if a patient has a metal.
My question is, using the dual source CT, whether can you able to get the soft tissue information as like MRI?
Like MRI, what?
Because it's a dual source we are using.
No, that is dual energy.
For example, 80 kV I can see both. 140 kV I will pass uric acid, I will not pass calcium. So when I subtract 140 to 80, I will know exactly where it is. That is dual energy concept. But
That's dual energy. Dual source are different.
My question is based on the application, we can go.
Yeah. So that is dual source. Dual energy or
Right now there is no competitor using dual source.
no, not at present. Dual source is, I think it will be more than 14 or 15 crores or even more. So at present we don't have any competition, and we don't feel that we will have any competition in coming 5-10 years. I think 10 years will be too much. 5 years, I guess. Fine. So you have no question, right? Right. So yeah, please, yeah, you can have my number, you can have the mail ID. If you got any concern, you can mail me. Alright.
Detailing CT both industrial and technical aspects. I request Mrs. Varshini Karthik, Assistant Professor, Department of Biomedical Engineering, SR University, to hand over the memento. of radiotherapy, and we are eager and would love to have another session from you, sir. I welcome Mr. Netra Nissan for the next session.
So, I'm going to speak on MRI, magnetic resonance imaging. Before I start, I was sitting with one of our customers, Dr. Srinivas Desai, who is the HOD Radiology in Jaslow Hospital, Bombay. And I shared this thought that tomorrow I'm going and giving a lecture. Maybe probably have to give an MRI as well. And I asked him for his inputs. What do you think? How is MRI going? And he said this magical words. He says, MRI is a Pandora's box. People don't know what is MRI. If you ask MRI, the basics of MRI to 10 people, you will have 10 different answers which are different from each other. That is MRI. Applications of MRI, people don't know. What to do with MRI, people don't know. So MRI is one such modality. If I see CT parallel to MRI, how it is progressing and where does the future lie? As rightly my friend said, we started with a point source and one detector in CT. We thought we need more coverage. We increased the fan beam. We made the point source to a fan beam. I got more X-rays. Still, the coverage was not there. What did I do? I increased the detector. So I got more dose, more coverage. So this started with 2 slices. What happened when I saw that I have 100 centimeters to cover right from my waist till my foot? Then came large number of detectors, which initiated 6 slices and 16 slices, which went on also to 40 slices. Then was an issue. I have moving organs. If I take a snapshot, I'll get a blurred image. The concept of temporal resolution. It is just as I rightly said before, there is a running horse, I try to take a picture, I get a blurred image. When will I get a correct picture is when I match the shutter speed to the speed of the horse. That's how 64 slides came in the picture. It's audible. So that picture where I can acquire cardiac with a temporal resolution. If you see a cardiac cycle, the acquisition time is 200 milliseconds. So my temporal resolution has to be less than this to acquire a particular image. So I came with cardiac CTs. I came with dual source. What next on CT?